Good afternoon. My name is Aaron Perez. I'm an engineer with the NDDOT Bismarck District. This breakout session is about HMA performance testing, and we're privileged to have three subject matter experts here presenting leading this panel discussion. To start off, I'd like to turn this over to Tyler Wollmuth, who's the Assistant Materials Research Engineer at the NDDOT, and he'll be introducing the rest of the panel. So let's welcome them.
Good afternoon, everyone. As Aaron said, my name is Tyler Wollmuth. I work in the Materials and Research Office. We put this panel discussion together because we had Ben Worel, who's with MnDOT, coming to present tomorrow morning, and Nener-Plante with Federal Highway Resource is also presenting, so I wanted to give them a little extra duty while they were here and talk them into talking about asphalt performance testing today. So I guess we're going to kind of do a hybrid here. We're going to do some slides with kind of what North Dakota and Minnesota are doing currently with performance testing and balanced mix design. And then Aaron has some questions that he's going to ask us kind of as a panel. We'll just pass the mic back and forth. And then once we get through those, we'll open it up to any questions we get from the audience. At the conclusion of that, we're going to go back down to Hall B, and we have our ideal CT crack testing device is at one of the booths. It's by the paving or the planning van in Hall B, so we're going to go down there. And one of our lab techs, Bob Usher, who works in materials, is going to actually demonstrate using the machine and break some asphalt plugs that we made this summer as we were going through and benchmarking our mixes. So I'll just go through a few slides here, and then I'll pass it over to Ben. He can talk a little bit about what Minnesota's doing, and then we'll get into some questions. So first thing I wanted to introduce y'all to is a pooled fund that North Dakota joined this past year. It's called Demonstration to Advance New Pavement Technology. We joined this pooled fund, so we pay in a dollar amount each year. This is a federal highway pooled fund. So in return, what Federal Highway does with this one is they basically give you money back to use on a demonstration project. And there's some stipulations that go along with that. But I like to call it the free money pooled fund because we're putting $40,000 into this, and in return, they're giving us $250,000 towards a research project. So we're using that $250,000 towards the project of implementation of balanced mix design. We also went through our research advisory committee, and we asked for an additional $100,000 there. That's why up on the screen you see $350,000 total. And because we're also members of another pooled fund called CAPRI, which centers around asphalt research, we were able to reach out to the National Center for Asphalt Technology, commonly known as NCAT, and we went to them to do a research proposal. And because we're in CAPRI, we were able to basically transfer this money to the other pooled fund and have NCAT do this research on our behalf. So this project will run for about 4 years. We just had a kickoff meeting here at the end of December. This will be a 4-year project. With this project, we're going to build some balanced mix design test sections. We're working on a pilot project right now that we're hoping will be constructed in 2024. So we'll put together some criteria for what we want to see and build some test sections with that. Kind of the end goal of that research project would be for NCAT to help us develop some balanced mix design specs and then start implementing some of these strategies through some pilot projects. So what we've been working on with North Dakota DOT, and we purchased some asphalt testing equipment using the STIC grant, and we put that to use in our bituminous lab. I talked about Bob. He's going to be breaking some plugs here after this talk. He did a lot of the work in our lab as well as some of the other staff down on materials. But we tested 39 projects this summer. 12 were carryover projects from 21, and the remainder were paved in 22. And we ran them through Hamburg wheel tracker, which is our rutting test. Ideal CT is a cracking test, and the DCT is a cold weather cracking test. So we ran all those mixes through that. We have all that information on the results downstairs at our table or our booth where that equipment is. So if there's a project you're interested there, you can see what we got for results. So cracking test, just to give a quick overview of kind of what we got. This is an index, so it runs it through this machine, it graphs a curve. It's basically measuring an area under a curve and then giving it an index value. So on the ideal, higher number is considered better or higher cracking resistance. We were, as most states are doing this, found out we're all over the board. So we had as low as an 8 and as high as a 444. Our average was 66 for all those projects we tested. You know, kind of the national theme right now for ideal is you're probably going to want to be over 50. You know, it's kind of a benchmark that a lot of people are looking at. So our average overall was above kind of what that national benchmark has been set at. We also ran the DCT, which is the cold weather cracking. You can see our range and our average there. MnDOT's really kind of been a leader with the DCT. They're shooting for above a 450, and we averaged a 481, just to give you some kind of results there. And that test is run inside of a chamber. It's run at -18 or -24 C, depending on which asphalt cement that you're using with your mix. The rutting test that we did is the Hamburg wheel tracker. We ran these at a standard kind of 20,000 passes with one temperature. You know, as we get further into balanced mix design, we could modify the number of passes that we require kind of based on traffic levels and the amount of truck traffic you have on that road. But just for this benchmarking, we decided to run them all the same, so we set the machine to 20,000 passes, and it'll run to 20,000, or if it hits that 12.5 millimeters before that, it'll shut off, at a certain pass number. So 12.5 millimeters is equivalent to 1/2 of an inch. So that's what we're looking at, is less than 1/2 of an inch of rutting in 20,000 passes. So the average that we found on the projects was just over 17,000. It ranged from a low of 9,300 to several that went the full 20,000 and weren't at that 12.5 millimeters of rutting. The other thing this measures is stripping inflection point, or SIP. And that's basically telling you if that asphalt aggregate interaction is coming apart. Like I said, these are in hot water when this test is running. This is kind of a torture test, if you will. So this is trying to really pull that sample apart, and that's kind of what that stripping inflection point tells you. So there we average about 13,000. We range from a low of 51 to a high of, again, where we hit the full 20,000 without seeing any stripping problem. One thing we kind of identified just doing this benchmarking is definitely an area in the southwest part of the state where we found a stripping issue. The muddy water there in that picture, that started out clear. So as that test ran, it was pulling some of the fines out of that sample, and it was kind of pulling that sample apart. And that's the left picture there. You can see the one that has a lot of rutting and the one that has very little rutting. That left one would be that project in southwest part of the state. So we're kind of hoping as well, just with knowing the rutting and the cracking, to try to identify some of these areas where we may have some aggregate quality issues and try to get ahead of that. So with that, I'll turn it over to Ben. He's going to talk on a few slides, just kind of where Minnesota is at, kind of in regards to balanced mix design and HMA performance testing. So turn it over to him.
Well, thank you, Tyler. You went through all the testing, which is great. I just had a couple different slides. This is what happens when you don't coordinate slides beforehand, but you'll see what happens. And again, my name is Ben Worel. A little background, I guess I've been working with different performance tests for a number of years, and through a number of these studies, there's some of these up here you can kind of see, but I've worked with MnDOT for 25 years now, and some of the earliest stuff that we did related to kind of coming up with a balanced mix design, especially on the cracking side, is kind of looking at the low temperature cracking pooled fund. We did a pooled fund study a number of years ago with 4 prominent universities around the country, trying to come up with the DCT and the SCB. There's 2 different types of tests at that time. We're trying to figure out which one worked and what were the different properties and how those different components of the mix affected this test. And really we came down to that both these tests look fairly good, but they are complicated, and I'll get into that a little bit later on talking about where Minnesota's at right now. But again, we developed those original tests, and this is probably 15 years ago, the Low Temperature Cracking Cold Fund, that went probably for 6 years, those 2 studies. Then we started working with NDDOT, and we have a great partnership with NDDOT with the Mineral facility. Again, it's 2 test tracks, north-south. You know, when we start talking about performance tests up here in the north, we're talking mostly about thermal cracking, thermal fatigue, that kind of thing, whereas down south they're talking about fatigue cracking. So that's their cracking test versus kind of the northern cracking test. But again, some of these tests that we worked on, you can see a number of those there that, you know, we tried all these different things out there, and in a lot of ways, there's some really complicated tests. You got to do the test just right. You got to have the sample just right. You got to have everything just right to get the results. But we did, just like North Dakota, we saw that there is promise, because when you do it right, it does show that some areas with the different areas, the different things that we got going on, we could make some improvements for the future. And I think hold that thought a little bit. Again, NCAD MnDOT, we did a cracking study that's just finishing up right now, where we built test sections at MnDOT that we expected to fail and ones that we didn't expect to fail, so we'd have different fracture energy. We saw mixed results with that over the last couple of years when we built those test sections, but NCAD built test sections down at their facility to look at the fatigue cracking, the alligator cracking, if you want to call it that. So really, you know, we've also been doing a lot of internal studies, just like North Dakota, where we've been doing a lot of stuff related to DCT is our test, and looking at that test, focusing on that, and trying to get it so we can use it for mixed designs. We can also use it for field work, so the whole quality assurance, quality control. And it's not really easy because they are complicated and long. So I guess in a nutshell, we're seeing that these tests could be very well for mixed design side right now, in the meanwhile, but in doing the field tests, it's just too complicated and too slow right now, really, when it comes down to it. You know, it was interesting when I put this presentation together. I went to the 2 guys that were doing the lab tests in the Maplewood lab in MnDOT. And then I went to the bituminous engineer and I said, okay, I'm giving 4 slides, and it took 2 meetings to come up with these 2 slides, which I thought was really interesting, how research is looking at it one way, but the operations people are looking at it another way. So keep that in mind as we move towards this. But again, I think it is a good thing. It's just a matter of kind of working it out over time. It's not an easy road. We'll talk about that more during the discussion. Right now, we're kind of looking at the simplified split wedge test, you know, as a one test that might be a little more simpler to do in the field. Gyratory specimens, it's more of a fast test. But there's a lot of literature related to all these different types of tests and the pros and cons of each through our research efforts at MnDOT and NCAT. So where are we at in that? We have not implemented balanced mixed design yet in Minnesota. Again, we're participating in a peer exchange that's coming up with agencies nearby us in North Dakota, Minnesota. But we're trying to kind of look at, we do see a purpose of this, and there is a future to it. It's just how to get that and work that into more common practices that we have. That peer exchange is happening on March 21st in Illinois. Really right now, we've really developed a good DCT database with many mixtures in Minnesota. Again, did a lot of trial specifications and implemented 4 projects in 2018, so we've been doing it for a few years. But really what's kind of interesting that's come up with is that we're seeing that if the PG grade is a -34, that's the low temperature grade, there's the high temperature and the low temperature. So if you're hitting a -34 low temperature, our garden variety in Minnesota is like a 58-28. But if you hit that -34, we're really seeing that pretty much it passes all the tests for that minimum fracture energy. So you got the guys in research saying, well, we got to research it more, and then you got the guys in the field saying, well, no, he's passes all the time, let's just use the minus 34 PG grade, that's a heck of a lot easier. So that's kind of the quandary we're at right now. But, you know, I guess we're working towards that. Let's do one thing there. And I guess, you know, right now we're using the Hamburg for rutting. That seems like a great test. As Tyler pointed out, it's a great torture test on stripping and rutting together. We're also, really rutting is not a concern in Minnesota. We don't have a rutting issue to speak of, but it's good. I think I've heard people in the past say that once you start worrying about, just like if you have two kids, you worry about one, then the other one falls off the shelf. You worry about the other one. So it's kind of the same thing, whereas I think in the past, in the 70s, we didn't worry about rutting, or we worried about rutting, we made our asphalts really dry so they wouldn't rut, but then they cracked. So again, it's that balance that we're looking for. The DCT, again, is one we're looking at using for it's not really lends itself for production testing, but could be used, it works really well for mixed testing, for mixed designs and things like that. Leaning towards the ideal CT, the SWST test is a production test that's more simplified. But that's kind of where we're at in Minnesota related to performance mixes and balanced mix designs for asphalt pavements. What's that?
Just advance that one.
Oh, then I guess I had some stuff that I don't know that much about. Derek probably knows more about this, but this is something that came up with this national standard. There's different approaches you can take for balanced mix designs. NCAT helped develop this through NAPA. But again, we're kind of looking at more of the approach A when it comes to the different approaches that we'll be taking into the future. Derek?
Just sitting here. All right. So my name's Derek Nener-Plante. I'm not going to use a mic.
Because they can't record it.
Oh, you're recording it? Okay, I'm going to. Hello. Now. Okay. So Derek Nener-Plante with the Federal Highway in our resource center. I do all things asphalt across the country. And so sometimes I'm told I'm contractually required to talk about balanced mix design wherever I go, because you can't escape it. Any sort of asphalt meeting or something like that, it has to be talked about apparently. But I do a lot of work in helping agencies look at balanced mix design. And, you know, nationally, the trend very much follows what Tyler and Ben talked about with North Dakota and Minnesota. I'd say the majority of states are investigating balanced mix design or moving that way at this time. There's a lot of questions that remain, and what does that look like? It's different for each agency, and I think that's the good thing about balanced mix design, and that it's going to take into account some of those items that aren't taken into account by our current system. It makes sense that the mixes here in North Dakota should probably be a little bit different than those in Florida, right, for a number of reasons. And some of our existing systems don't always take that into account. So I think that's a good thing. We're seeing, you know, agencies have different goals for balanced mix design, and there's a lot of benefits that they're chasing to try and get into it. I think from Federal Highway's perspective, that's a very good thing to set out. What are you after? What are you not here? I would tell you it's coming, all right, if it isn't, but to use some sort of recycled material that our existing super paved system doesn't really handle after a certain point. After a certain point, it doesn't work as well. To allow more innovation, to let go of some requirements that maybe don't relate to performance as well as these other things do. So I think it's really kind of moved down the line in agencies want to specify what matters, right? You know, want to specify things that give performance in the end, all right? And move to these tests. The hope is that that will move that down the line a little bit to allow different ways to achieve performance that we all know. The thing that I bring up is our existing super paved system, whatever it is. Here in North Dakota, it's by FAA, right? So your 12.5, FAA 45. Do all those mixes perform the same across the state? And I don't think we get anyone in the room to say, oh no, they perform exactly the same. They're exact same product, right? Even the producers, you guys know what are your good mixes and maybe the mixes that you still love, like your kids, all right? Let's take Ben's example, but you know, they might cause you a little bit more headache, right? We're hopeful that balanced mix design will pick up those differences between those mixes, right? Where our existing system treats them. So that's where there's a lot of investigation nationally, and a lot of states are following, you know, doing much what Minnesota and North Dakota are doing. There are a few states that have implemented balanced mix design in some way, shape, or form that are at full implementation. There's only a couple, and there are more getting closer each day. But there are those out there that lessons can be learned from. So, good question, Ben. So who is that? Illinois is one. Illinois first implemented the Hamburg wheel tracker for all their mixes, and then they implemented the Illinois Flexibility Index test. Their implementation is for all mixes statewide. That was their goal. Another one is Louisiana. Louisiana, same thing. They had the Hamburg in there, and then they have their cracking test, the SCB, their own version of it. They do it only at mixed design, but they're fully implemented. Sometimes it gets moved past, but states like New Jersey and Texas are examples as well. They've used these so-called performance tests for years on their specialty mixes. By specialty mixes, stone matrix asphalt, high performance thin overlays, flexible crack attenuating mixes over, you know, that ugly concrete stuff. So to prevent reflective cracking, things like that. And they've used tests like this for those high performance mixes. They don't use it on everything, but they use it successfully on those. There's even those in New Jersey, they don't even spec the binder grade. They say, meet this performance test, and a couple other requirements, the rest is up to you. Okay, so use whatever binder grade you want, as long as you, now it took them a while to gain that confidence, but that's kind of a vision of the end goal. So.
Great questions?
All right, we got a few questions here to ask the panel members. Derek, might as well just start with you.
All right.
The Matic trailer promotes and showcases new technologies to state DOTs and organizations, and was in North Dakota in 2021. How do you decide which technologies to purchase and use in the trailer?
Yeah, that's a good question. So I work with the Mobile Asphalt Technology Center, the MATSI, and again, we were up here, one of our first visits after COVID. So, you know, we deploy a lot of these BMD tests. I think in choosing them, where we've looked at what are the agencies looking at, you know, for potential implementation, what is, you know, I hate to say popular, you know, but again, and also what is valid, right? What has shown some promise to be valid, and there's a mix. You got from, to me, it's a trade-off. You have tests that take longer and probably are more fundamental about the material, but they take longer. Okay, they take a long time. You have the ones that are simpler, which means they're faster, they can be done more, maybe they can be done more real time, but you trade off with simple, right? With simple, you're not gonna catch as much fundamental. So we have a range between there. Again, I think it very much depends. For us, it's trying to demonstrate the different ways that those different tests could be used for an agency. So we use a wide range for any agency that's looking at tests. You gotta think about how you wanna use it, you know, because that's gonna develop your trade-offs and how to pick.
It's not only the test itself, but it's also the sample prep. There's a sample prep is the other side of it too, is you gotta make the sample just perfect to get it to work. You know, that slows it down too, but once you master that, you'll get consistent results. Similar to what Derek said.
Yeah, I guess I'd just add, that's an excellent point, that in a lot of ways, even the most complicated tests, it's not the test that makes it harder to do or take longer. It's all in the specimen prep. A lot of it is really in the specimen prep that we're not used to. We're used to pounding it out at a certain number of gyrations, putting it in some water, running some Wright's gravities, and that's it. This takes another level of coordination.
Let's see, Derek, let's you with another one here. You know, Tyler and Ben kind of talked about how far along we are with implementation in North Dakota and Minnesota? I know you kind of touched on other states and where they're at too, and some are going with implementation. Would you say that North Dakota and Minnesota are kind of in that big group of states that are just trying to figure it out right now? Or where are we at compared to the rest of the nation?
I'd say you're right in the big group where everyone, a lot of states have selected tests or preliminarily said these are the tests of interest. We want to see where our mixes are at. There are some that have probably been doing that for a little bit longer, been collecting that information for a little bit longer, but not too many. Then there are the states that they're doing it because all the other cool kids are doing it, like, oh, well, everyone else is going to B&B, we should probably do that too. But no, yeah, I'd say that's pretty consistent that you're probably both states are in that large group that's in the collecting information phase, which is going to take some time. BMD is not something that you're going to implement in 9 months because it is really a pretty radical change.
Here's a question for all of you guys. So we'll start with North Dakota, looks like. This can just go down the line here. What tests are we running now, and what tests are we looking to maybe explore in the future? And maybe that's more of a Matty trailer question.
Yeah, so I guess North Dakota, what we did is, we had the Matsi trailer here in 2021, and they had a lot of insight for us testing our mix, up in that minor project. Just talking to the guys in the trailer and the crew that was out here. There's definitely some kind of national favorites, I would say, as far as test procedures and which tests they are. And one advantage we have is a lot of states that started before us. They tried several different cracking tests and kind of figured out which one was for them. We were in a position where we were a little bit further behind on getting some of this, so we had some neighboring states that already had some experience. And we went to Wisconsin and we went to Montana and we did peer exchanges with them. And we ended up getting the same equipment that both of those states have and that the Matsi trailer has, which is the Ideal CT, which is the machine we have downstairs, the hammered wheel tracker, and then the DCT, which is the cold weather tracker. So we had an advantage of kind of following some other states in our region, and they kind of did some of the trial and error and kind of weeded out the tests that we thought would work for this area. So that's all I meant to put it.
Yeah, I'd echo that. A lot of states initially had wider nets. They cast wider nets on the tests that they looked at. Some would started with 3. Virginia is an example that started with 3 or 4 cracking tests and then whittled it down to 1 with their own little evaluation of, how easy is it to use, what's the throughput, the validity of it, is it sensitive to their mixes, etc. I see a lot of states now, just again, I joked about the peer pressure, but I think copying other states is where some are at and saying there seems to be coalescing around the Ideal CT and the Hamburg, or the Ideal CT and maybe the APA for those states that still do the APA rut tester, and then maybe the Ideal RT on the rutting side, as that has the potential to vastly increase throughput, reduce testing time. But many are kind of approaching it that way.
Yes, I already kind of said what we were working on how to get is the DCT, the Ideal CT, the SWST, but then the Hamburg on the rutting. We were using the APA. We found that Hamburg was probably more of a torture test that seemed like Minnesota's always wet, and that's going on all the time anyway, so that's kind of a 2-tested one in a way.
I guess you can hand that back to Ben there. How has MnDOT used asphalt performance testing in recent years to evaluate how mixes will perform on test?
Let's see, did you listen, Mike?
Well, just taking it a step further.
He wrote this a little bit. Yeah, it's always been the question. It's like thermal cracks were such a problem. Early on when we started looking at our original tests at MnDOT, it's interesting when you look at thermal cracks because like we built thin sections and thin and thick test sections. So we built like 6-inch and 9-inch. We built ones with a 64-22 and a 58-28. Even in the early years, it went down to -40 and we had a cracking event. And what was interesting is that thermal cracks don't care if it's a thick or thin. it's environmental. I think before that, we weren't even thinking that. We were thinking, is it even related to loading and things like that? There's still little debates on that. But, the whole idea, it's not the thing, you can't build your way on the thermal cracks. It really is an environmental distress. Really saw how 58-28 worked better than a 64-22. For 15 years ago, we weren't really even thinking that way, or longer than that, I guess, before 2000, before the super pay came out. And then we built test sections even a couple of years later with a 58-28, a 58-34, and a 58-40. And this was when PG grades were just getting going and the tests were being accepted, but we saw a 58-28 crack like we normally saw. We saw a 58-34 didn't crack at all. And a 58-40 cracked like crazy, which really makes you wonder but that's when we started dumping the engine oil into our asphalts to get to a -40 PG grade, which we've learned from that too. So lots of different things, plus all the pooled funds that we've worked on. It's been a long, long road getting to the point where we're at. And it's sad as a researcher to say, geez, wait a couple more years. But I think, again, like I say, the goal is to get better mixes, and I think this will help provide better mixes with the variability that we have out there with, wrap, arid sources, different sources of binder. There's a whole number of different things that these types of performance tests can look at once. There's so many variables out there in asphalt mixes that you kill yourself trying to chase them all, but you come up with that one test, that's going to be a really quick way, or probably the quickest way to get to the end that we want, better performing mixes.
Okay. Here's one for all three of you guys. I think you touched on it a little bit here, but we're using these tests to predict long-term performance. So we've been doing volumetrics for a long time. So I guess when you're trying to talk someone into getting away from volumetrics into the balance mix design, how do you start those conversations?
So I think, what Ben's last slide up there showed is there's 4 approaches to balance mix design. The first one is to do everything you're doing now and then add rutting and cracking tests. The furthest one down the line is don't do any volumetrics. Give a rutting parameter, a cracking parameter, and let the contractor figure out how to meet those. Don't specify a material type, don't specify a binder grade, just say, contractor go out and innovate and, put in whatever you can put in to meet these. So there's kind of a broad range of where you can go with balanced mix design. And I think most states are going to start on that low end and say, we're still going to do volumetrics because we still trust it and what it gives us now. But we want to improve our mixes by, saying we can meet this cracking number and this rutting number. So, DOTs don't move fast when it comes to that kind of spec change and that kind of, philosophy change. So, it's going to be a process of first, benchmark our mixes, see where we're at now, start to fold some of this in with, having a mix design requirement, say, for rutting and cracking. And then, the next step is going to be, can we do this in production testing? And if we get to that point and we get these test procedures working and we get more comfortable with doing this, then we can move to the area of, okay, there's some volumetrics we can start not measuring. And we can measure rutting and cracking, and we don't need to rely on material-specific gravity maybe as much, or we don't need to have specs for certain things like air voids. If we're meeting rutting and cracking, those kind of become consistency measurements and not quality measurements. So I think that's kind of what our approach will be, is first learn where our mixes are, and then start down that path of how far can we go with balanced mix design.
I think it's an excellent question and a good thing to bring up, because I think the messaging on balanced mix design sometimes gets a little fuzzy, and that we'll implement the ideal CT and some other test and nothing else will matter. Okay, these tests are not complex enough to catch everything. They are not. If they were complex enough to catch everything, they take a week to do. So I think of it as, I don't like the term volumetrics are going away. We have an effort that where we're talking to contractors nationwide. We hope to have a tech brief that's going to summarize how contractors are meeting performance tests in those states. And guess what they're doing? They're looking at volumetrics and gradation. They're not starting from scratch. The most common thing that we've heard for meeting cracking tests is achieving VMA, something that we already require in volumetrics. It just might be, for this aggregate source, it might need a little bit more VMA. For this one, I can get away with a little bit less. So to me, it's going to be more of volumetrics are an excellent tool to show that the product is consistent, that the product being made today is relatively similar to the product being made tomorrow. We have that well known. I think what BMD gets us is whether it's any good or not. Is it going to meet our performance expectations? So I could more see BMD telling us what mix meets and what doesn't, and volumetrics being kept around for consistency. But maybe it's not 4% voids. Maybe 4% voids isn't right for every mix. Maybe for this one it needs to be 2.5, or for this one it's 5. So the target doesn't necessarily matter, but keeping voids in control in production, to me, I don't see a situation where that would want to go away. Because again, even the simpler tests, I'm not sure you're going to be able to do it often enough to catch all the variability in our process. But again, I'll kick my soapbox off to the side. And I'll give you that.
All right, I guess I agree both statements here. I guess kind of branching off what you're saying, you know, the volumetrics is going to be really good for the plant. I mean, you kind of need that as guidelines on how to do things correctly. The other aspect that's coming up is, you know, the whole thing with rejuvenators. You know, how are these going to kind of fill into places? Fibers, plastics, rubbers. You know, we're starting to pull funds with NDDOT on that. Again, building test sections at NCAP and at Bin Road. But again, how do these all affect both balanced mix design? You know, there's always going to be something new coming down the road. You know, when it comes to even our loadings that we expect in the future, if there's been, you know, automated vehicles, things like that, rutting. You can see a really strange thing. We talked about square ruts at lunchtime here with you know, so I mean, you got vehicles going in the same place all the time, that's going to really change the whole game plan. But again, having a test like this will help us into the future, I guess, going back.
All right, last one I got here, then we can open it up to the audience for questions. This goes to Derek again, sorry. Tell us about any resources that FHWA is providing on balanced mix design going forward. I know you guys have done a lot for us already, but kind of going down the line, what can we expect?
Yeah, so we were here with the MADC, so that's certainly a great resource that North Dakota has taken advantage of. And we've also done a virtual, but this one was in person, BMD workshop that I think went pretty well last month. Last February? Yeah, last month. I forget the amount of times I've been to North Dakota. It's been a lot. So, but, you know, that's there. But I think we're also putting together peer exchanges. Ben mentioned it. That Minnesota's going to be participating one. We're going to be putting one together for this region, hopefully in the next year or so, to get states talking to each other. Are there ways that different states, understood we know we cross that state line and physics change and everything changes once you go from, you know, one Dakota to the other. But that, you know, what are the things that states can collaborate on so that not everyone has to reinvent the wheel when they implement EMD. So we're going to be active in trying to do that, and again, synthesize a lot of the information that's out there so that people can learn from what other people are doing.
Anyone out here have any questions? Got a few minutes left.
I got one for Tyler. When you guys are benchmarking, are you also looking at Super Phase 5 or reduced gyration counts when doing some of this benchmarking?
So that's kind of been a separate topic. We did run the Super Phase 5 project through our benchmarking. And you know, we're going to have one or two more Super Phase 5s coming out this next construction season. So I think that's kind of a little bit of a separate path. You know, it's a different way, and there's a Super Phase 5 presentation this afternoon that you all can attend. But we haven't really tied that with BMD at this point. You know, as far as benchmarking, we treated all the projects the same. We run the same tests. We did find with the Super Big 5 project, I think that one did fairly well in cracking resistance. That aggregate source of that project came out, it probably wasn't as good on running as some others we've tested, but it was, I would say, a passing test. But no, we haven't really combined the two together. I think Super Big 5 is kind of a separate path from BMD right now for us in that, maybe it's a different process for looking short term at the way we do our projects and the way we, spec it the way it's in that. So.
I guess this would probably be more for Derek. With the amount of money and effort we're researching these pavement ideologies, is there like any thought of reinvigorating like SPS 1 again to like get some of these down on the road to actually correlate index tests to real performance, so that, or is that like a agency to agency's responsibility?
I think at this point, that's been more of an agency to agency thing. I think the LTPP program, unfortunately, kind of ran its course, and that was before I joined Federal Highway. But I echo your sentiment that if I were back in an agency, what I would do is build test sections today, as soon as you can. Because guess what? Time is your biggest enemy. Any test I don't actually like the term performance test, because anything can be a performance test if it relates to performance, right? We thought that air voids and VMA and all these things do, and they do, but we're hoping that these things are better. So if I were in someone else's shoe, I'd say build test sections now, because you want the time, and make that not, my last thing, and I've heard this during the workshop too, BMD is not gonna be somewhere balloons fall from the ceiling and confetti falls. We did it, we implemented BMD, we're done. All right, let's not go back. That's the mistake we made with SuperPay. All right, we didn't check that what we were doing actually related to performance. That to me is going to have to be a continual process, because if anything, BMD I think is going to become more important with anything that wants to come into paper. Again, repeat for Tyler, but I read a paper that I thought was an Onion article, and it was real, from overseas, where they used diapers and a mile of roadway. They ground up the used diapers to get the fibers from diapers and put them in the asphalt. So if you think anything can't make it into asphalt, anything can, all right? So, and SuperPave can, for real, Google it. I really thought it was fake, but, so that's where I think it's important to keep that in mind and to be able to, no matter what we do, know what we got for testing, what we got from that material, and how did it perform in the field. And the best time to start that is today, all right? The second best is tomorrow, etc. So, I lied about the soapbox, but I'm still standing on it, sorry.
Well, it looks like we're at the end here. Let's give our panel members a round of applause.